right, so now we're looking at a bond, corporate bond, which is very different from stock. For bond, the cash flows are not unlimited in assumption. Instead, you have a maturity for bond. In this question, you have a 10-year bond. So basically, that tells you the maturity is 10 years. Okay, and you have the coupon rate, which is 4%. Okay, that's 4%. And also, this is a semi-annual bond, indicating the frequency is 2. Okay, 2 for each year. So copy paste right here. And then you also have yield to maturity of the bond, which is the discount rate. That is 8%. And of course, the face value of the bond is always $1,000. So what is the fair value of the bond today? So what is the price today? Right, that's what we're solving for. Okay, so one way to do it is actually using the present value function of a bond. And remember, it is a semi-annual bond. So for the 8%, we have to convert it from an annual rate to a semi-annual rate by dividing it by 12. Okay, so 8% divided by 12 is going to give you 4%. And then the number of periods, instead of having 10 periods, 10 years, is actually 10 times 2, 20 periods in 10 years. Okay, so that's 20 semi-annual periods in 10 years. And then for the payment is 4% coupon rate. It is 1,000 face value times 4% coupon rate, and that's the coupon payment for a year. And then you need to divide that by 2, which would give you the semi-annual coupon payment. All right, so basically 1,000 times 4%, that's $40 divided by 2, that's 20. Each 6-month period, you're going to receive $20 for coupon. And then the future value will be 1,000, all right, and then the type will be 0, okay? The payments are made at the end of each period. And then you have the present value, that is $728. And I don't mind you to convert it to a positive number just to show the price of the bond. All right, so cut and paste it right here, $728. Or you can just list all the cash flows generated by the bond. So let's say we have all this period. Instead of using year, I'm using period. From 1, 2, and all the way you have how many periods? Well, you have 10 years. So that means you have 20 semi-annual periods. Semi-annual means a half a year, you know that, right? So that's 6 months. And then for the cash flows, for each period, you're gonna get 1,000 times the 4% divided by 2. So that's $20 for each 6 months you receive for the coupon. And then for last year, it's the same as the $20, okay? So it's the same as last year, so on and so forth. And then for the very last year, okay, it is a $20 plus the 1,000 face value. So not only you're receiving a coupon, but also you receive the full face value of the bond. All right. So right here, I'm going to discount, okay, or get the present value of the cash flows. So right here, I'm going to use a 20 divided by 1 plus this 8%, the yield to maturity. Well, yield to maturity of the annual term, we know that, so we have to divide it by the frequency, all right, and then raise to the power of the year number, discounted by 1 period, okay, 1 6 month. I'm going to lock the face value, the yield to maturity, and also lock the frequency to make sure when I drag it down, that number stays. Okay, double click. You will see that I keep using 8% divided by 2 as the semi-annual discount rate, and then I will shift my periods for compounding, okay, for discounting. So that is basically the present value of all the cash flows generated by this bond. And then to get the present value, I just simply add them up. Okay, all the numbers added together is $728. So that's how we got the present value for the bond. There's another method which I do not quite require you. If you know it, it can be extra credit. So you have a settlement date, you have a maturity date, and you have a rate, you have a yield to maturity, and you have a frequency, you have a basis. So this is actually pretty hard to do. So especially for the date, you don't have the date, you have the time to maturity. So you can improvise two dates. So you see 2018 and then 2028. Okay, the rate here is yield to maturity. The rate is coupon rate first, followed by yield to maturity. And the redemption value is 1,000. Frequency is 2. Okay, the basis is 0, and see what I got. Right. Well, it does not quite get me the result because the settlement and maturity date are not the same. So let me just say settlement date is January the 1st, 2018. Okay. Or okay, and the maturity date, let's say it's 10 years later. Okay, revise it. This is the same date, but 10 years later. Okay, so now my settlement is not a number, it's a cell with a date. Okay, let's see what I got. For the redemption value, which is 1,000, I need to divide it by 10. Okay, and then for the price, I need to multiply it by 10. Okay, because everything here is in $100 basis other than $1,000 basis. So that's another way to calculate the bond value using the price function, right? So you can see that I have two dates that have 10 years in between. Okay, one is called a settlement date and another is a maturity date. And then you have this rate as coupon rate, yield to maturity at 8%, frequency is 2. The only thing is the redemption here is divided by 10. So it is, if you don't divide that by 10, then you would get wrong result. And after you get the price, it will be multiplied by 10 to get the full price of it. Okay, so in the price function, the prices, no matter for face value or present value, are all measured in hundreds, not thousands. Okay, so just to let you know. Okay, for the last question, you need to draw a curve with the x-axis as the interest rate, yield to maturity, or we can also call it interest. And then the y-axis would be the price of the bond, okay, or the present value of all the cash flows generated by the bond. So what I want you guys to do here is to start your yield to maturity at 0%, and then I want you to have a 5% increment each time as you drag it down. So you select the first two rows, you drag it all the way. So you will have this series of returns just to stop at 16%. Right? Do you see that? You create 0%, you create 0.5% by typing, and then you select the first two cells, drag it all the way until you reach 16%. So this will be your X values. And for the prices, you need to get the present value of the bond, which incorporate the rate. So the rate here for the yield to maturity is 0%, and you know it's a semi-annual bond, so you need to divide that by 2. Okay, you need to divide that by 2. And you also have a number of years. So you have a 10 years. The thing is, it's a semi-annual bond, so 10 needs to be multiplied by 2 to get a total number of periods, which is 20. And for payment, the payment is $1,000 face value times the 4% coupon rate. Okay, 4% coupon rate. Well, the thing is, the payment is made on a semi-annual basis, not on an annual basis. So you need to divide that by 2 for each period. Okay, and then the future value is 1,000. The type of payment is 0. Okay, so this basically is telling you the price of the bond would be $1,400 if there's a 0% discount rate with the current term. And I recommend you to switch to a positive, okay, to a positive $1,400 to represent the price of the bond. The reason it was negative is because the Excel would recognize the direction of cash flows. If you receive a coupon, if you receive the face value, today you need to pay the $1,400 price. In our this scenario, we just need to make sure these are positive prices, right? And all you need to do here is pretty simple. Just drag it down, right? Just drag it down or double click. So you will see that you keep using different yield to maturity or the discount rate, while all the other numbers remain the same. Okay, so these are your X values, yield to maturity, and these are the Y values. There's another way for you to do it. You can use the data table. Okay, so in the data table, you need to put a yield to maturity here, face value. You have a coupon rate. You have the time to maturity. You have the frequency. Then you need to put in all the numbers. So for now, let's put a yield to maturity at 0%. And the face value is 1,000. Coupon rate is 4%. Time is 10 years. And the frequency is 2. And then the price of the bond is combining all of these numbers. The price value, our rate is 0% divided by the frequency of a 2. Let me just make it 2, not 2%. It's general. Okay. So price value of the 0% divided by the frequency, and then you'll have the number of periods of 10 years times the frequency, and then the payment is 1,000 times 4% divided by 2. That's your 6-month coupon in dollar, and then comma 1,000 for the face value, 0 for the payment period. Okay, so that's $1,400 as we agreed earlier. Okay, just to change it to $1,400 positive. And here I'm going to copy this yield to maturity, this column. All right, just put it here. And then I have the price. So I'm not going to do it here. Just delete this one. Okay. So the price, instead of having the price here, I want it to link to the cell right here. Okay. So just to make sure this is linked. And then I want you guys to select the whole area. Okay, 2 rows and many rows and 2 columns. And I want you to hit data. All right. And I want you to hit what if analysis, and then hit this data table. So what I want you guys to hit is pretty easy, just to replace this 0%. Okay. So what happened is your Excel knows that it's gonna derive a series of numbers based on the formulas provided by this 1,400. You know the present value for the formula, and it will replace 0%, 0.5%, 1%, all the way to 16%. Every row each time to this yield to maturity of 0%. Okay, so if you replace 0.5% to this yield to maturity, this price would change to a different value, and your Excel will record it as a different value right here. And it is a row, it is actually a column input. So it's actually a column input because all the numbers here are in a column. And then hit enter. All right, now we have the perfect result generated by the data table. So let me clean it up a little bit. Oops. Okay, so just this row. Okay, just want to make it a dollar sign and decrease decimal. There you go. Okay, as you can see, instead of drag it, I just do it all at once. Why do I bother to use the data table? Right here, you can just simply drag it all the way down, right? Just one operation and that's it. The thing is, this number could be adjusted. In a later case, you may change the face value, you may change coupon rate, you may change time and frequency, and all the factors will change. The thing is, this formula does not comply with all the changes. So you need to have something more sophisticated, which would incorporate all the components and their changes. So that's why this data table is more advanced. The last thing is to draw a curve. So you can use this data or this data, it does not matter to me. Just select it, and I want you to do insert. All right, and I want you to insert a scatter chart, and I want you to have the scatter chart with straight lines and markers. Okay, this is your scatter chart. All right, so you will see this is your X values are the yield to maturity, all the interest rate. The Y values would be the bond prices, and you can highlight this, just click this chart and then do a quick layout. Click on layout number 1. Then I want this to be the bond price, and I want the x-axis to be yield to maturity or interest. And the topic is price versus interest. Okay. So this is your legend, which is the price curve. Okay. So now this project is finished.